Control flow is all about deciding where to run code based on if a condition is true or not, or deciding if to repeatedly continue running some code while the condition is true. This concept is a fundamental building block in programming. The most common control flow statements in Rust are if statements, and then there are three types of loops. So let's go ahead and look at what an if statement is. So we'll start out by saying let 1 equal 1, and then we can start an if statement with the if keyword. So we'll say if 1 is greater than 0, print out true. So we are checking to see if the condition 1 greater than 0 is true. But if it's not, then we want to print out false. And that's what the else keyword does. Else is going to be our fallback plan. If none of these other conditions are true, then this is the block of code that we want to evaluate. So we know that 1 is greater than 0, so we got true. But if we said is 1 greater than 10 and we ran it, now we fall back to our fallback plan of false. That way we have logic for if any of our conditions are not true. Another thing that we can do is we can chain in multiple conditions. So with the else if keyword. So now we can say is 1 equal to 1. And if it is, we want to print out equal. So now if we run this, we expect equal to print out, and that's what we get. And you can have as many else if chained together as you want in order to accommodate for all possible conditions that your program might have. And that's just the basics to the if statements. So now let's go ahead and start looking at some of the loops. So we'll comment that out. And the first loop that we're going to look at is a while, or correction, is a loop, with the keyword being loop. So to show you what a very simple loop is, we'll say, hey, I just want you to print out loop. And this is going to be an infinite loop of the word loop, printing out. And as you can see, that is what we're getting. So we can do Control-C at the same time, and that's going to send an interrupt to our program so that we can exit out of our infinite loop. So now let's get a little bit more sophisticated with this loop, and what we can do is actually we can give our loop a name. So in this case, I'm going to name a loop called counter. And then inside this loop, I'm going to print out the count. And I'm going to set it to num. And I need to create the num variable. So we'll say let mutable num equal to 0. And then what we'll do is we'll create another variable on the inside. Let mutable decrease equal to 5. And then we're going to create another loop inside of our loop. So now we have a nested loop, and you can have as many nested loops as you want. The more loops you typically have will start affecting your big O notation, which is the spatial and time complexity that your program may have. So inside this loop, we are going to print out decreasing and point that to decrease. And then we're going to add in some if statements. So if decrease is equal to 4, break. So this is our first keyword inside a loop. So what break is going to do is if this condition is true, then we're going to break out of the loop. And the loop that this break is referring to is the loop that we're currently running in, so the innermost loop. But now we're going to create another if statement that says if num is equal to 2, so our variable up here, then we want to break out of counter. So this break is actually referring to our outer loop, which we named counter. So what we're going to do now is we're going to decrease by 1. And what this statement is saying is essentially decrease equals decrease minus 1. It's just shorthand for it. And then outside of our innermost loop, we want to add 1 to num. And this is the same thing as saying num equals num plus 1. So now if we run this, we see that down here we started out with our count at 0. That's correct. And then we decreased from 5 to 4, which is correct. So we enter this loop with our decrease at 5. Decrease is not equal to 4, so we don't execute the break. Num does not equal to 2, so we do not execute this break. But now we decrease by 1 and we stay inside this loop. So now our decrease is 4, and now we can break out. So we break out, we increase our count, so our num by 1, which is what caused this count to now print out 1, and we repeat the loop again all the way until our count equals to 2, and then when our count equals to 2, we satisfy this condition, which lets us break out of our outermost loop, which we named counter. So you can have as many loops as you want inside one another, and then based on your logic, you can stay in a loop as long as you want, and then you can set up logic on the inside to be able to break out of loops when conditions are met. So another type of loop that we're going to look at is called a while loop. And a while loop will run while a condition is true. So to very simply show this one, we're going to say while, well, first off, let's create a mutable num equal to 0 again, and then we'll say while num is less than 5, print out num. I want the value. We'll reference our number, and then we will add 1. So now we'll run it out, and you can see that we printed out and got 0, 1, 2, 3, and 4. And once we hit 5 with num, our condition was no longer satisfied because 5 is not less than 5. So we broke out of the loop. But now if we said less than or equal to 5 and then ran it, now we also included 5. And that's how a while loop works. So now let's look at a for loop. And a for loop is a great way to loop over elements of a collection. So think of a vector. So let's do vec of i8 equals to 0 to 10, and then we want to collect those values and put them in there. So then for element, so to start a for loop, we use the for keyword. Element is going to be our variable for accessing all the values inside. So for element, aka all the values inside our vector, in, and then what's our actual vector's name that we want to reference? Well, it's vec. So for all the values in vec, let's print them out. Print line. And then we want to print out what the element is. And as you can see, we printed out 0 to 9, which is what we expected. So now a fun little cool one that I can show you is we can create a for number in 1 to 4, and then reverse it, print line, and then we want number. And then afterwards, when our countdown is done, we have liftoff. Clear, run it, 3, 2, 1, liftoff. So we created 1 to 4, not including 4, reverse it, print it out, and then exit the loop and provide or print out liftoff. And that's all it is to loops. So loops are very powerful. You're going to use them all the time throughout your code. But now we have successfully gone over all the basics of programming.